Hey there and welcome back to the Code Wrinkles channel for a brand new video, maybe the most controversial video that I have made so far on this channel, because today we will try to answer the question if we should use or if we shouldn't use repositories when we use Entity Framework Core. Now, this is a debate that actually lasts for years and it actually never came to a certain conclusion. And I'm actually very baffled that there are some very strong opinions that are also, I would say, dogmatic. So maybe there are some people that say you should use repositories, and then if you don't use, then you are doing something wrong. And of course, there is the other side that says, okay, if you are using repositories, then you are totally doing something wrong. And actually, it's something. It seems to me a bit like it's something like politics or religion. You can't really change the mind, and the opinions are very strong, and everybody thinks that the other side is wrong. And I would like to bring my 2 cents into this debate because I think that things should be a little bit nuanced. It always depends on a context, and it always depends on different things. And there might be contexts or scenarios where repositories might help you, and there are contexts or scenarios where repositories might actually not be needed at all. So it's not a one size fits all. It always depends on what exactly you would try to achieve. Now, in order to get this discussion going, I would like to show you exactly maybe the most clear example that you will get out there. What actually is the difference when using a repository, or when using repositories in general, and when not using repositories? Of course, in both cases, we talk about using also Entity Framework Core, so we also have a DB context. Now, to start this going, I would like to say that, first of all, the arguments, the arguments that the people have that say that, okay, you should not use repositories, is because the DB context itself already implements the repository pattern and the unit of work pattern, and all the DB sets actually in a repository, or sorry, in a DB context are actually repositories, and the DB context itself is the unit of work. And that is correct. That's totally true. On the other side, even if they are repositories, the DB sets, and the data context, the DB context is a unit of work, you might want in certain scenarios maybe to abstract this away through an interface. And let's get first to our code and take a look at two different projects. And I promise you that by the end of this comparison, you will also have better tools to understand exactly the different scenarios where repositories might or might not be useful. So the first example that I want to go through with you is this very simple application that we have already used for a different video on how to structure a clean architecture. So we follow the clean architecture principles. Now, what do we have here, for instance? Of course, we have the domain layer, which is named core in our case, which for our discussion right now is really not relevant at all. Now, we have then this application layer, which is, according to clean architecture terminology, use cases layer. Now, in this use cases layer, what we have actually, we have two interfaces. So we have an interface for a iWeather forecast repository that just exposes one method right now. It's clear this project was built only for demo purpose. And then it also has an iWeather forecast service interface. Now, we have here in this use cases layer, which should once again do all the necessary application level logic and work for your application. So this would of course include also working with data, but also processing the data, doing a lot of stuff with the data after you get it, and before you maybe save it once more in the database. So that's why we expose these interfaces here in this layer. Now, when it comes to the service, as the service is part of the, I would say, application logic or application business rules or application flows, of course, we implement here this service in this very same assembly. Now, of course, here we can have another discussion because it could be a best practice to actually extract all the interfaces, all the abstractions in a different project that kind of would still belong to the application layer, but it would only contain abstractions. And then here we will have the implementation for the service. Like this is the implementation for the service. And as you see, the service actually relies on the iWeather forecast repository, because as a service, it probably gets some data like it is in our case, and it does some processing on the data. It does something with the data because that's what applications do. They do something with data. And then, of course, it returns a result of that. Now, this is what we implement here in this application layer. Now, the interface for the repository, once again, we have defined in this layer, but the implementation of this interface is done here in this infrastructure layer, where we have, of course, this weather forecast repository that implements the interface iWeather forecast repository. So in this case, the flow is actually very, very simple. This, of course, injects a data context, which is our DB context class, of course. And well, it just returns some forecasts in an array. That's what we do here. So once again, here the flow is that we have our core application logic or our application level logic and flows in the application layer. There we define all the functional interfaces that would need to be implemented by any other layers, but on which the application layer resides, because it needs to get data. If you make calls to third-party APIs, you need to get the data from the third-party APIs and things similar to that. But that's why we expose these interfaces here in this application layer. So this means that here we also implement the weather forecast service. In the weather forecast service, we inject the repository. And of course, in the repository that is implemented here in the infrastructure layer, we inject the data context. So this is the very first, very standard layered application using also, of course, clean architecture, but also repositories, or this very, I would say, common approach to have repositories and to inject those repositories into the services, and the services will then perform some stuff based on the data with which they interact. And that would be awesome, and it actually works for a lot of applications. This works quite fine. Now, before we actually go into the part that I wanted to actually show you, I want to go into a different application, which conceptually it does exactly the same thing, but it still uses clean architecture. So we have this application layer, but it uses the CQRS approach. And here we have commands and queries, and we have handlers that would be responsible to handle each of the command or each query. So that's how we actually set up this kind of, or this is how this, or what this architectural pattern CQRS actually prescribes. So we have actually these handlers. Now, the thing is here that in our infrastructure layer, we have a data context. It's actually the same data context, but we have no repository. And if we look into the application layer, we have no interface at all. Instead, we just expose some commands, some queries, and some handlers. And if we take a look at the handler, for instance, we see that in the handler, we inject directly the data context, which is our DB context, our EF core DB context. So in this case, in the handlers that are part of the application layer, because once again, they model how the application works, they model how the application flows. By doing this, or while doing that, those handlers might need to also have access to data, of course. So we just want to provide them this type of access, and that's what we do here. So it's also very simple. Here we actually don't have any repositories. Here we just have handlers, and in the handlers we inject directly the DB context. So I guess you get here these two different type of comparisons. On the one side here, we have a very standard layered application where we have a service layer that actually relies on repositories that get injected into it, and use the repositories actually to get some data. And the key thing here is that the interface for the repository is actually described or defined here in the application layer, but the implementation is done in the infrastructure layer. And we have on the other side a different project which essentially does exactly the same thing, but the difference is that here in this case we just use CQRS. So we use handlers, and we actually interact with the data directly in our handlers without exposing any interfaces and without, of course, having any repository. Now, Let's go one step further. And I'll go back here to this layered application where we don't use handlers, where we have services and repositories. And I would like to use a very nice feature of Rider, which allows us to actually show a project diagram. And let's take a look at this project diagram, which also includes, by the way, transitive dependencies. So this actually shows us all the projects in our solution and how they are actually related, on how they are dependent on the other projects or not. And here, if we take a look, we have this weather forecast API, which of course is dependent or depends on the weather forecast application layer. And it also depends on the infrastructure layer. But very important thing, it depends on the infrastructure layer because actually the let's also enable code coupling. It depends on this infrastructure layer only because we actually do one very simple thing. We add here the DB context, and that's actually everything that we do here in our project. We just use that. So it's very important that in this kind of setup, the only reference in your API project or front-end project to the infrastructure should be because you are adding the DB context to the dependency injection container of ASP.NET Core. Otherwise, you should always interact only with the application layer and do your stuff through the services that this layer exposes. Now, we have then this application layer, which is kind of like the key here in what I would like to show you. And if we take a closer look to this application layer, we see that it actually has no dependency at all on the API project and on the infrastructure project. And this is why we define the interfaces in the application layer, but the implementation in the infrastructure, because the application layer only works with the interfaces, with the exposed interfaces. We don't really care in the application layer who implements that interface, how it implements the interface, what technology they want to use. We don't really care about that. In the application layer, we just care that that interface should be implemented, and that's it. And the application layer uses just that abstraction, just that contract, just that interface. And therefore, it actually doesn't depend at all, not even remotely, to the infrastructure project or to the API project. Now, let's switch things and go over to the other screen where we have this CQRS approach. And here, let's do exactly the same thing. So we go on architecture, show project diagram, and we get this type of diagram. Now, if we take a closer look here, we see that these things are actually inverted. So you may here is this one. So we have here on the button, we have this weather forecast, this infrastructure layer, and then the application layer. So if we are at the other one, we see that we have the application layer and then the infrastructure layer. So what we see here already is that in this case, our application layer actually depends on the infrastructure layer. And it depends on this layer because we actually inject the DB context, which is part of the infrastructure layer, in our handlers. And that's why actually in this case, our application layer is dependent on the infrastructure layer. While in the other case, where we used repositories that are exposed to interfaces, we see that our application layer is not at all dependent on the infrastructure layer. And that's really, from my point of view, the major point or the major difference in this debate of using the repositories or not using the repositories, because everything depends on a context. Now, if I am in a context where there is a certain requirement, could even be from the business, that we should not have any dependencies between these two layers, then of course we might need to use repositories and abstract it away, implement that in some layer, and in the application layer or services layer or however you would like to call that, you just use that abstraction and work with that. You don't care who implements that. So here we have everything is totally decoupled. So the application layer is decoupled from the infrastructure layer, and that's actually a very, very good thing. Now, if we go on the other side, we see that this is not the case, because in our case here, as we inject the DB context in our handlers, so once again, we can even take a look at that. So if we inject DB context in our handlers, which are part of the application layer or services layer or whatever you want to call that, that's already a dependency. So we already depend on the infrastructure layer. Now, you might say that, okay, maybe it is bad that we depend on the infrastructure layer, and maybe it would be desirable to not depend on it. But once again, this depends a lot of the different scenarios and a lot of the different, I would say, characteristics of the different way to structure software and systems. Because, for instance, if we go towards a very standard layered architecture where we have like domain services or like services, and we use them also repositories, the problem is that when we use services, usually what it would happen, and maybe let me go to that screen. So what it would happen, let me go to the service implementation. It would happen here that, of course, first of all, we would have a bunch of different services. But then what it would also happen is that those services will become very big very fast. And you would say, yeah, but we can refactor. True, we can refactor. But in practice, customers very, very seldomly actually pay for refactoring. So this idea that you create services and then you'll refactor on the fly, in most projects will not happen. And you will end up with a de facto service that has, I don't know, maybe 1,000 lines of code or even more than that. And then there's the problem that you need to unit test that. So in order to test that, you would have to actually, well, first of all, either use some real data and do integration tests, which of course are useful, but we also need to do some deeper unit tests on that. Or you could mock, for instance, the things that can be mocked, like the data access layer. However, the problem here is that it is very difficult to actually mock an entire DB context. And that's why actually when we have this type of architecture where we have very big services that rely, of course, on the data access layer, maybe it would actually be better to have repositories that are exposed through an interface, because when we create a unit test project, we could easily swap the implementation and provide some mocks for it so that we can still unit test correctly. So in this approach, when you have a standard layered architecture with services that, as I said, tend to become very, very big, it might be a good idea to actually decouple this layer actually, or the service, from the implementation of the database itself. And this is what we achieve actually through using this repository. However, on the other hand, you could imagine, for instance, let's go back just 1 second, that if we have a very big services, let's say we have here, I don't know, maybe 20 methods like that. So 20 methods that kind of like do something with the weather forecast or with a bunch of weather forecasts for that matter. So let's assume that. Now, the whole thing is that if we go to a CQRS approach, actually what it will happen is that for each of these methods that we have in the services, if we switch to the CQRS approach, we will probably have handlers. So handlers are very self-contained piece of functionality. And as they are not part of a very, very big class with a lot of methods and with a lot of dependencies, they are easier actually to work with. And also, if you go for CQRS, you might also probably want to have a rich domain model. So if you have a rich domain model, then you can do basically all your unit testing on the domain model itself, and you can only integration test the handlers. So in this case, if we have the CQRS approach, it might be actually more helpful for us to actually don't have this, useless, in this case, abstractions to depend on, because we have here very small classes that actually encapsulate only a very tiny bit of functionality. And in this case, it's really easier to actually do anything with that. Also, imagine a different scenario. Imagine a scenario which to be honest, doesn't occur very, very often, but it's totally possible. But let's imagine a scenario that says, okay, you have an application and you are using Entity Framework Core, of course. And at a certain point, somebody says, or the CTO or somebody from that specific company, we should switch to use something else, maybe a non-relational database or whatever, or maybe just use Dapper instead of Entity Framework Core. So all these type of scenarios might be actually possible. Now, let's think a bit. What would happen if we are right now in a situation where we have, for instance, this service layered application with, once again, big services that all rely actually on data access? Well, actually, this would mean that if you would use this DB context directly in the service, you would have to go in each of the methods and actually implement the new way of working with data. Now, if you have a repository that actually exposes an interface, theoretically, you could build under the hood a different implementation that uses a totally different technology stack, and you could simply just swap it when you register it in the dependency injection container. Still, in this scenario, we would still have some problems, because as these services are very, very big blocks that kind of rely on really the same instances of services that get injected, or of repositories that get injected here, you would actually, when you want to actually switch a service from one database provider to another, you would most probably have to switch the entire service at once. Or you could also go for strategies that you would have maybe two different layers and switch method by method, but still, it will get a little bit messy. But if we have repositories, that's also still manageable. However, if we are in this other scenario, once again, and we have exactly the same thing, so we have Entity Framework, and we use the data context here directly in the handlers. Now somebody says, okay, we want to actually swap this, and for, I don't know, for the query handlers, we want to use Dapper. Sure, no problem. We just go here, insert Dapper instead of the data context, do the stuff that we need to do. We only have to change code in this handler. It will not affect any other handler. So we can simply do the change handler by handler. So even if we depend directly here on the data context, you can easily, for instance, swap implementation one handler at a time. And this would also allow you, of course, to make this kind of migration during a longer time period, because there's no way in the world where you would swap everything at once. You still need to proceed in phases, the one way or the other. The only thing that I wanted to showcase here right now is that in comparison to the services that are very big classes that have a lot of things injected into them, and each method depends on different services or repositories that were injecting them, it's very hard to really keep track about what is doing what. Using repositories will totally help us, of course, because we can just swap the implementation, and as long as the interface remains the same, everything should work. But we can also then maybe try to maybe upgrade or do these changes one at a time, or in a method at a time, or service by service. But still, it would be a little bit more complicated, while in this other approach, since everything or each handler is self-sufficient and fully encapsulated, and it actually has all it is, and it doesn't affect any other handlers. It's perfectly fine, because here you can just come here and simply go and swap this around, and everything should be fine. Now, as a bottom line to this entire discussion, once again, I just want to maybe show you maybe the most important reason why you should, or why you would use repositories, or why you wouldn't use repositories. And all that reason actually is, or resides in the fact that when you are using a repository, you can decouple your services layer or your application layer from the infrastructure layer, while when you are not using repositories, you have your application layer actually coupled to the infrastructure layer. And here, everything in software engineering and architecting and programming is about trade-offs, negotiating trade-offs, knowing exactly the pros and the cons of each approach, then actually compare that to the scenario, to the exact context in which you actually need to design and build an application. And based on an informed knowledge about how things work and what are the pros and the cons, you can make then the best decision that fits your exact context. Now, that decision might be to use repositories, that decision might be to not use repositories. No matter the decision that you take, if you take the decision knowing exactly what would be the pros and the cons, then it would be a good decision. And I would like to actually conclude with something like a very, very basic advice. When it comes to software programming, whenever you see or hear debates that are very, very dogmatic, like you should use repositories, you shouldn't use repositories, which is the best programming language, you should never try to actually jump on the bandwagon of one of the sides. Instead, try to actually remain somewhere in the middle. Try to understand exactly all the arguments from one side, the arguments from the other side. Just be informed. And when you need to actually make a certain decision, then be informed, evaluate, calculate the trade-offs, the pros and the cons of each of the different approaches, and use what best fits your context. And that's actually what I wanted to share with you. I hope that this content was what you were looking for, because in my opinion, it's not dogmatic at all. It's just trying to actually offer you all the tools and showing you exactly the main difference between using a repository or not using a repository, so that when you face this kind of decision, so that you would have all the knowledge to actually evaluate the pros and the cons of each of the approaches, and then go for the approach once again that fits your context best. That is the most important thing. Now, if I have achieved this with this video, that I am very, very happy, and I thank you very, very much for watching. And if you think that this content might be useful also for others, don't be shy and spread the word. Share it with your colleagues, with your peers on forums, wherever you think there might be people that would find this type of video interesting. And also hit the thumbs button and the subscribe and the notification bell, of course, to just be notified whenever we have something new for you, because we try to deliver a lot of good stuff, hopefully. And this being said, once again, thank you very, very much for watching, and until the next time, I wish you the very best.